Hi everyone. So today we're going to talk about using Cpctc in your triangle proofs. It's the abbreviation that stands for corresponding parts of congruent triangles are congruent. So basically, in your proofs up until now, you were getting triangles congruent. And when you are working on a proof now, if you notice that the proof does not say triangles, but it says something else, like here we have FG congruent to FJ, then that's like your red flag that you're going to go one step farther and then use Cpctc at the end of your proof. All right, so let's try this one. The first thing we'll do is just list our givens. So FH bisects, it's saying two things. FH bisects angle GFH, or GFJ, and angle GHJ. A lot of letters that sound the same. Okay, so that's given. That's actually our only given, but it's saying two things. So let's look. If FH is bisecting angle GFJ, so that's GFJ over here, that means it's cutting it in half. So that would tell us that angle 2 is congruent to angle 1. So even if we don't quite know how we're going to do the rest of the proof, let's at least say that angle 2 is congruent to angle 1. And it's because of the line that's bisecting, so you could just say definition of bisect. All right, and then the other angle that FH was bisecting is GHJ. So that tells us that angle 3 would be congruent to angle 4 for the same reason. So angle 3 is congruent to angle 4, and that's also because of the definition of bisect. All right, so now we know that in all of our proofs so far, we're trying to get triangles congruent. And we have two congruent angles, but if you notice, they share a side right in between those angles, which is FH. So in step 4, we could just say that FH is congruent to FH, and that's because of reflexive. And now we have enough to say that the two triangles are congruent because we have ASA. So in step 5, let's write the triangles. We'll say triangle FGH. And if we go in the correct order for the other triangle, that would be triangle FJH. And to determine the order of the letters, I always just follow the congruent markings. So in the top triangle, I said F first, which had the single marking, and then G, which had no marking, and H at the end, which had the double marking. So the reason I knew to say FJH for the other triangle is to just follow those. Single marking, no marking, double marking, so FJH. So that's just how to write the order of the letters. And so that is ASA. And if you need to list the previous steps that the ASA was in, one of the angles was in step 2. The S, the side, was in 4. And the other angle was step 3. So then, this is where the new thing comes in. We're ready to say our proof statement. Right after you get the triangles congruent, you can usually just say this proof statement that they wanted you to prove. FG is congruent to FJ, which is true because of our new reason, Cpctc. And it's just because FG and FJ are the corresponding or the matching sides of the two triangles. So since the two triangles are congruent, then we know that those two sides have to be congruent to each other. So let's try one more. So I'm going to start by listing my givens. Circle O, and the fact that they said CD is congruent to DE. So given, given. And I always say that if they tell you that something is a circle, then be on the lookout for congruent radii. Radii will always be congruent in a circle, so that's the key thing that the circle helps us with. So I'll mark given number 2, which was that CD was congruent to DE. So that was already given to me. So now we know we're trying to get triangles congruent because that's the most common thing that we do in our proofs. So I am noticing right away there's 2 radii right here and right there. Those are both radius of the circle. So I can say in step 3 that CO is congruent to EO. And the reason that I give is just that all radii are congruent. Now the triangles are almost congruent. I think the most logical thing to say next is just that OD is reflexive to OD. So OD is congruent to OD because of the reflexive property. All right, now we have our 2 triangles congruent. So if we just highlight them, it's triangle CDO and triangle EDO. So step 5 is to say triangle CDO is congruent to triangle EDO. And that is because we have all 3 sides congruent. So SSS, and if you need to list the steps those were in, that's just steps 2, 3, and 4. There's nothing else except for our very first given. And now, because we're trying to prove not the triangles, but those 2 angles, it's most likely going to be Cpctc. So let's just check to be sure. Angle COD is right here, and angle DOE is right there. And those are 2 angles that are corresponding or matching with each other in our 2 triangles. So we can say angle COD is congruent to angle DOE because of Cpctc. You know, they keep the proofs pretty similar to each other in the beginning, so basically you can just know that once you get this triangle step congruent with using SSS or SAS, whatever you're going to use, the very next step will be your proof statement, and the reason will be Cpctc. All right, and that is it.